is basically just an introduction to the terminology that's going to be used in Chapter 8 when we go into more details. Okay, but a solid, some of the terms that you need to be familiar with. Okay, a solid is that which has length, breadth, and depth. That's the historical definition for it. Okay, so you are going to see the term solid. And solid is just something that encloses space. It encloses 3 dimensions of space, and length, width, and depth. Okay, so any 3-dimensional object would be considered a solid. It doesn't have to fit into a subcategory quite yet, but we are going to talk about some categories of solids. Okay, the other terms that you need to be aware of is the faces of a solid. The faces of a solid are just the surfaces. Okay? So you'll see the surface, you'll see the word face, you'll also see the word base. A base is just a more specific name given to one of the faces or surfaces of a solid. Okay, and then finally, terminology-wise, we're going to start talking a lot about, really there's 2 types of solids that we're going to focus the most on. Solids that have only polygon faces are called polyhedron. The plural of that is polyhedra. And so those are solids whose faces are only polygons. And so most of what we're going to talk about solid-wise will be polyhedra. Okay, but we're also talking about some solids with curved surfaces that'll be formed by rotating a figure about one of its elements or parts. And those will be called solids of rotation. So really polyhedron or polyhedra and solids of rotation will be the solids that we'll talk most about. Right, in extending these polyhedra, there's a specific set of them that are called the Platonic solids. There are 5 of those. They're also referred to as regular polyhedra. Okay, so these are the 5 solids that are formed that have regular polygons as their surfaces. So in these 5 Platonic solids, every face is a regular polygon. And not just a regular polygon, but it's all the exact same regular polygon. So it's not like there's equilateral triangles mixed with pentagons or hexagons, right? Or squares. It's all the same exact regular polygon. Okay, as far as what you need to be able to do regarding these are all defined on page 20. So you don't necessarily have to copy down these definitions, right? As long as you know where to go to find them. But what you have to be able to do with Platonic solids is you have to be able to identify one if you see the illustration of it. And so that's why I included these illustrations. Okay, a tetrahedron is the Platonic solid with 4 equilateral triangles. Okay, tetra is the prefix meaning 4. Okay, a cube is the Platonic solid with 6 congruent squares. Okay, this is also, if we were counting by the number of sides, a hexahedron, okay, where hexa is our 6, because there's 6 total faces, 6 congruent squares. An octahedron has 8 equilateral triangles that enclose a space. An icosahedron has 20 equilateral triangles that enclose a space. And then finally a dodecahedron, that's the prefix for 12, and it has a solid, or it has 12 equilateral, equiangular, or in this case regular pentagons as its faces. Okay, so what you probably need to be able to identify is the most common one, which is a square or a cube. But really, if you see a picture of something and you notice that every lateral face is an equilateral triangle, as in the case of these 3, you need to be able to understand those are Platonic solids, or in this final case here, the regular pentagons. Okay? So again, it's just a matter of classifying, identifying it to fit into a specific category. All right, questions on those? Again, you don't specifically need to come up with these terms on your own. Okay, but if it asks you to identify a Platonic solid, you're probably going to say cube. That's the easiest one to do.